Hey there everybody, welcome back to more Pre-Calculus 11. So this video we're going to do our final notes for Unit 2 with quadratic functions and quadratic equations, and after this we're going to move on and move away from quadratics for a little bit anyways. Really what we're going to look at here at the end is you've been building up all these different skills for solving quadratic equations, and now we're going to just put them into practice. We're going to do some of these word problems and we're going to solve them that way. Now any of the skills you've got, you can use any of them to solve these problems. For example, one of them is by graphing. So I'm gonna solve these without using the graphing method, but just know that you've got your calculator handy. You could always solve it one way and then just plug it into your calculator and solve it with the calculator to find the roots, find the zeros, and then that would tell you if you've got the right answer and certainly give you an idea of how close you are. So with these word problems, you know, they are often the most challenging problems that students face, and the biggest challenge that they have is setting the problem up initially. Okay, so let's take a look at this one. So the sum of two numbers is 20. The difference of their squares is 80. Find the two numbers. Okay, so let's write down what we know here. So the first thing we need to do is kind of define some variables. So the sum of two numbers is 20 and the difference in their squares is 80. So I'm just going to start setting this up, and I'm going to show you one of the most common kind of roadblocks students run into. So if I just say number 1 is x, and then number 2 is, let's say, y, for example. Well, then I can start to write some equations that will let me maybe figure out what these are. So this first statement here, the sum of two numbers is 20. So that just is telling me that x plus y is going to equal 20. But I also know the difference of their squares is 80. So I know that, for example, x squared minus y squared, the difference of their squares, is going to be 80. Now, the problem I'm facing here is I've got two different equations and that I could solve. I just can't solve them because they've kind of got two variables in them, and there's a few different ways to do this. But what I want you to recognize is if we can get either of these equations so that they only have one variable in it, so it's only x's or only y's, then we can just go through and do our solving. So what I noticed right here is that I see that x plus y is equal to 20. So what that tells me then is that y is actually equal to 20 minus x. I just move x to the other side. So if I do that, if I say y is equal to 20 minus x, now what I've done is I've kind of written both of my variables just in terms of x. The first number is x, the second number is 20 minus x. And so I only have one variable to work with. What I can now do is I can take this right here, this expression 20 minus x, and I can put it in here for y, because y is 20 minus x. And what that's going to do is it's going to eliminate one of my variables. So I've got x squared. So I've got x squared, and then I go minus, and in brackets here, 20 minus x all squared, and that equals 80. And now you can see what I've got is I've got an equation, and it only has one variable in it. So it's not pretty, but I can work through this to solve this for x. So let's see what happens here. I'm going to just expand this out and collect. So I've got x squared, I'll write it over here, minus 20, let's do it like this, 20 minus x times 20 minus x equals 80. And then now let's expand out. So x squared minus 400, and then I'm going to get minus 20x minus another 20x is going to be minus 40x, and then plus x squared equals 80. But then don't forget that this negative sign here, this negative sign gets distributed across the entire bracket. So everything here becomes negative. And so I'm going to have x squared minus 400, negative times a negative is plus 40x, and then minus x squared equals 80. And when I collect like terms here, you can see that I actually have this x squared and that x squared are going to cancel out. And so if I rewrite what's left behind, then if I rewrite what's left behind, I've got negative 400 plus 40x equals 80. And I'm just going to move negative 400 to the other side by adding it. So I get 40x equals 480. And then I'm going to divide both sides by 40. And I get x equals 480 divided by 40 is going to be 12. Okay, so x is 12. And don't forget that y is 20 minus x, so 20 minus 12 is 8. So the two numbers are 12 and 8. And I know that they add up to 20, but I also know that 12 squared is 144, 8 squared is 64, and so when I subtract them, the difference is also going to be 80. So again, this didn't turn into a quadratic problem. As it turns out, the x squared canceled. But the point is still the same, where you want to get everything in terms of one variable or the other, instead of having two variables. So let's try this one here. Find two consecutive odd integers, odd numbers, so that the sum of their squares is 130. So if the first number, can't go wrong with having the first number equal to x, let's think about what that second number could be. I know I could just call that y, but I would just get stuck. So I have to put it in terms of x. If I have two consecutive odd numbers, so if they're odd integers, 1, 3, 5, and so on, and consecutive just means one after the other. Well, basically we're going to skip over that even number. So the first number is x, the next number will be 2 higher than that. So the second number will be x plus 2, because they have to be odd. If they were just consecutive integers, then it would be x plus 1. And we know that the sum of the squares is 130. So I guess that means that x squared plus x plus 2 squared is equal, the sum is equal to 130. So we can see I've got everything in terms of x, and so I can just crank this through and solve. I'm going to expand this out here. X squared plus x plus 2 times x plus 2 equals 130. So that becomes x squared plus x squared plus 2x plus another 2x is going to be 4x. And then 2 times 2 is 4, so plus 4 equals 130. I'm going to collect my like terms, and I'm going to bring the 130 over to this side of the equation by subtracting, and I'm going to collect these terms here, and I would get 2x squared plus 4x. Let's see, 4 minus 130 is going to be minus 126 equals 0. And that's something that I could factor, hopefully, and then start to solve. Before I do factor, I just noticed here that I can take out a factor of 2. So 2 times x squared plus 2x minus 126 divided by 2 would be 63. And that's going to equal 0. And then I can just divide by 2. And now that's just gone. It's out of my hair. Don't have to worry about it. Okay, so where am I at? I've got x squared plus 2x minus 63 equals 0. And so I'm looking for two numbers that are going to multiply to negative 63 that are going to add to positive 2. So factors of 63 include 7 and 9, and they're off by 2. And so positive 9 and negative 7, those will fit the bill. So I've got x, x plus 9 times x minus 7 equals 0. And so I can work out then x plus 9 equals 0. Well, that means x equals negative 9. And x minus 7 equals 0, so x equals positive 7. Now, remember what we said here is we're looking for two consecutive odd numbers that the sum of their squares equals 130. So I've got two answers here. I need to decide which of those answers is correct. Maybe both of them are correct, maybe one, or maybe none of them are correct. So I'm just going to try them both. if, I'm just going to say if x equals -9, then x plus 2 would equal -7. -9 and -7 are consecutive odd integers, and 9 squared, -9 squared is 81, and -7 squared is 49. Those add up to 130. So this is one possible solution, -9 and -7. Those work. But let's also check this one. What about if x equals 7? Well, if x equals 7, then x plus 2 equals 9. And I know those are going to work too. So there's two possible solution sets. We've got the numbers -9 and -7. That is one solution. And the numbers 7 and 9. That's another solution. Okay, let's take a look at something a little bit different, where this time I don't have to come up with the equation myself, which is often the hardest bit, but let's see what we can do. So I've got a football kicked with a vertical speed of 20 meters per second. Its height above the ground, h, after time, t, in seconds, is given by the formula h equals 20t minus 5t squared. How long after the kick is the football at a height of 15 meters? So if I know h, the height is going to be 20t minus 5t squared, how long, as in what is the time, when the football is 15 meters up? Well, that is when this whole thing equals 15. So when the height equals 15. And then essentially what I need to do, is I need to solve that quadratic. So I'm just going to shuffle some things around. So I'm going to move the 5t squared to the other side, and I'll move the 20t to the other side. And what I'll get is I will get 0 equals, when I bring this over, this becomes positive 5t squared. This 20t becomes negative, minus 20t, and the 15 is still there, plus 15. So I'm just going to go ahead and solve. Before I do, I think I'll take out a factor of 5. So t squared minus 4t plus 3. Took me a second. And that's going to equal 0. And so again, I can just divide both sides by 5. Divide that by 5. Divide that by 5, and then this is going to cancel out. That's gone. And so what I've got here is I've got t squared minus 4t plus 3 equals 0. So looking for two numbers that are going to multiply to be 3, but add up to be -4. So that's -3, -1, -3, -1. And so I've got t minus 1, and I've got t minus 3 equals 0. And so I can see from this that my possible answers are t is going to equal 1 and 3. And that's in seconds. So again, I've got two answers. Which one's right, I guess, is the question. Well, just at first glance, they're both positive. Like if we got a negative time, that would be crazy, and we know that couldn't work out. But is it possible that there are two correct answers? Well, if you have a football that gets launched through the air as it goes up in the air and comes back down, then it's going to follow this sort of path. And if this is 15 meters up, it makes sense to me actually that it will be exactly 15 meters in the air at two distinct times, both here and here. So in actual fact, both of those solutions are correct. On the way up, it takes 1 second on the way up to be 15 meters high, and then on the way back down, it takes a total of 3 seconds to go up and then come back down and again be 15 meters high. So once on the way up, once on the way down, I'm going to keep both of these answers. I'll just write in my units here. Cool. So let's look at one more here. Now this is kind of a tricky problem. We're going to get back to having to solve, having to come up with our own equations. And again, I mentioned that's where these get really tricky. So the cost of a graphing calculator is $100 each. At that price, 50 units will be unit? Don't think so. 50 units will be sold. For every $10 increase in the price, 2 less calculators will be sold. Find the price of the calculator if the company wants to collect $6,000 in revenue. So what we're saying here, and this should sort of make logical sense, that you charge a certain price for a product, and you know how much is selling, it makes sense that if you increase the price of that product, even though you might make more money because you're charging more, fewer people might decide to buy it. And if fewer people decide to buy it, well, then you're going to make less money. And so somewhere in here is probably this perfect ratio where you charge just the right price, you charge as much as you can, and there's still lots of people buying it, maybe not as many as it used to, but still lots of people buying it, so that overall you make as much as possible. And so we have to come up with an equation that's going to kind of relate these two things. So again, I want you to think about, well, what are we even calculating? We want to collect $6,000 in revenue. Well, how do we calculate revenue, the amount of money that a company makes? The revenue, the income for selling a product, is really just two things. It's going to be the price that you charge multiplied by the number of units sold. Right? Like, for example, right now they're selling them for $100 each. Right? So for $100 each, the revenue is going to be $100 times the 50 units that they sell is going to give them $5,000 in revenue. But they're hoping to make $6,000. So obviously this isn't the case. This isn't going to do that. They're going to have to charge more. So we then have to factor in some of this other information. They say, okay, they know that for every $10 increase, 2 less calculators will be sold. So we need to have a variable here that's going to allow us to kind of describe this situation. And I'm going to choose the variable x. But what does x mean? We're charging $100 now, and we're going to keep bumping that price up, 110, 120, 130, and so on. We're going to keep increasing the price until we get to that magic price point. So x for me, the variable, the thing we're going to change, is going to be the number of price increases. Okay? So if x is 1, then we charge 100 plus 10, we charge 110. And if x is 2, we charge 100 plus 2 times 10 is 120, and so on. And x just represents how much we're going to increase the price. So then our revenue function, which I'm just going to call r of x, that's our revenue function. What is the price going to be? Well, the price started at $100, but we're going to increase the price by some amount. And every time we increase the price, we're going to increase it by $10. So the price will actually end up being 100 plus 10 times x. Our 100 base price plus 10 times every increase. And then the units sold, well, right now we're selling 50 units, but that's not going to stay the same because every time we jack up the price, 2 less calculators are actually being sold. So if I start at 50, every time the price goes up, the number of units sold goes down by 2 times x. And we want this whole thing, we're hoping that this whole thing is going to equal 6,000. We want to make $6,000 off of it. So you can see here we've got an equation we can solve. There's only one variable, which is x, and we can just kind of crank through with our various tools to find the answer. So I need to expand this out, and that's what I'm going to do first. So 100 times 50 will give me 5,000, and then minus 200x, and then 10 times 50 is going to give me plus 500x, and then 10x times minus 2x is going to give me minus 20x squared, and this whole thing equals 6,000. So I'm going to rewrite this, and maybe I'll bring the 6,000 over to the other side of the equation. So I'll bring this over here by subtracting it, and I'm just going to move it so it's in my normal standard form. So I've got negative 20x squared, and then negative 200x plus 500x is going to be plus 300x, and then 5,000 minus 6,000 is going to be minus 1,000 equals 0. So I can, let's see, what can I do here? Well, I can actually factor some things out. I'm actually going to factor out negative 20 because I think that's going to come out. So negative 20, this leaves behind an x squared. Don't forget, when I take out a factor of negative 20, this will now become negative, and 300 divided by negative 20 will give me negative 15x, and then taking out a negative sign, this becomes plus, and 20 divided by 1,000 divided by 20 is going to be 50. And that equals 0. I can then just cancel this negative 20 out by dividing both sides by negative 20, and I end up with this nicer looking x squared minus 15x plus 50 equals 0. So we need to find two numbers that are going to multiply to 50 but are going to add to negative 15. And the two numbers that occur to me are negative 5 and negative 10. Negative 5, negative 10. So this becomes x minus 5 times x minus 10 equals 0. And so when I solve this for x, I see x can equal 5 or 10. And so the question becomes, well, which of those actually work? And so you can substitute these back into our equation, and we can just check them to see if they both, in fact, give me the result that I'm looking for. So imagine x equals 5. Then my revenue, R of 5, would just be 100 plus 10 times 5, so that's 150, times 50 minus 2 times 5, which is 10, so it'll be 150 times 40. And 150 times 40 is 6,000. So that one works. X equals to 10. What is R of 10? Well, 100 plus 10 times 10 would be 200. Multiplied by 50 minus 2 times 10. 2 times 10 would be 20, so that would be 30. And 200 times 30 is also 6,000. So both of those actually are solutions. Okay, one of them you charge a little bit more and you still sell lots. The other one you charge quite a bit more and you sell fewer, but overall you still hit that 6,000 mark. Okay, so that's it for word problems.